Hello everyone. Today we are going to be talking about factoring a polynomial. So this, if you can see, is a quadratic polynomial that we are going to be factoring, and it's in the form of ax squared, where the first term has a x squared, meaning quadratic. The second term is a bx, meaning a single variable, and the last term, a c, would be a constant. There are a variety of methods out there to solve this. Today, what we're going to look at in this video is a method which is strictly the AC method of factor by grouping. If you've seen the previous video where we were talking about factoring a quadratic polynomial where our a term or the leading coefficient was a 1, you don't have to use this method for that. However, the idea of the method is exactly the same, and you can still apply this method to the other simpler problems as well. So let's go ahead and get started. The problem we have is a 3x squared minus a 2x minus a 5. Remember, anytime we're starting to factor any given problem, the very first thing we need to find out or look at is there something, or is there a GCF, a greatest common factor, that can be factored out of the entire given polynomial? And if you look at this problem, there's nothing that can be factored out. It's simply a 3x squared, a 2x, and a 5. None of the numbers can be factored out, neither can the coefficients. Now, looking my checklist here, if I am looking at my checklist, the second thing I'm looking to see, which is to figure out which method I should be using, is count the number of terms. Does it have 2 terms? Obviously, no. This problem has had 3 terms. Now, if a problem has 2 terms, we're going to be looking at the problem and seeing if we can use the difference of 2 squares formula, which in this case is not the case. Next one, we look to see if it has 3 terms. Yes, this one does have 3 terms. We need to see if it is a perfect square trinomial. If that's the case, we can use the formulas. In a perfect square trinomial, the way we check to see is if the first term and the last term are the perfect squares, meaning can you take a square root of them? In this case, no, we cannot take a perfect square of a 3, neither can we take a perfect square of 5. So no, this is not a perfect square trinomial. So obviously a trinomial is not a perfect square. We're going to be using factor by grouping, or as I like to call it, the AC method. So that's the thought process we're going to use in order to figure out which method to use. Now, we're actually using the AC method. And the first step in using the AC method is to make sure if the trinomial is in a descending order. If it isn't, let's move it in a descending order. However, the given trinomial here is in a descending order since, as you can see, it's 3x squared. The leading coefficient is the x squared. The leading term is the x squared term. Then you have the simple x term. And then finally you have the coefficient. No need to worry about rearranging it. Next thing to check is if the leading coefficient is a negative, which in this case isn't. Now, we can't really factor anything as it is, so our goal is to take the middle term and split the middle term into 2 terms. The middle term is a negative 2x, so yeah, we can get a negative 2x from a variety of things. We could say, okay, I have a negative 5x plus a 3x. I could say I have a negative 2x plus a 0x. There's a lot of ways we can take it into a negative 2x. However, that's kind of equivalent of pulling things out of thin air, which we never allowed to do in our math class. We have to get to a negative 2x, and it has to come from within a problem. So the rule of thumb is we are splitting the middle term from the construct of the first and the last term. So we're going to go ahead and rewrite our first and the last term exactly as it is, and we are actually going to come out on the side and use those to figure out what we need to do for the middle term. So I'm going to come out on the side over here, and I am going to take the positive 3x squared and times it with a negative 5a, which gives me my product of negative 15x squared. Now in this problem, by the way, this is what we like to call the AC product, and that's where the name AC method comes from, because we're really actually working with the AC product to figure out what we really need to do. Now, what I would like to point out in this case, in this problem, you only have one variable, x squared, so it's pretty straightforward. When you have, let's say if your first term was a x squared and the last term was a y squared, in that case, I would recommend keeping the variables as you are figuring out the two factors you need to keep. Now, the name of the game here is to work with the 15. We need to split the 15 into its different factors. The factors of 15 that we can work with are either 1 and 15, and happens to be a 3 and a 5, and that's pretty much it. So which one do we keep? What's our testing mechanism? We are going to keep a factor that we are able, obviously this is a factor of AC product, so when you multiply it in any form, it'll give you back the AC product. Now, the other thing is the test we need to figure out is we need to pick a factor that's going to either add or subtract to give us the middle term. So in our head, we're thinking, can you add or subtract 1 and a 15 to give me a 2? No, it's not going to happen. So we're going to focus on 3 and 5. What are we going to do with the 3 and a 5 to get me the 2? And that's going to be the subtract. Now, obviously, we know based on our signed integer rules that it can be either a negative 3x with a positive 5x. That's going to lead me to a subtraction. Or it could be a positive 3x with a negative 5x, which could also lead me to 2, subtraction. Which one are we going to keep? And this is where I'm going to highly recommend you to actually check both cases, because you want to make sure that you are getting the right sign and the right number. So when you work this out, you get a positive 2x, whereas if you were to work this out, you get a negative 2x. So obviously, looking at our middle term, we know we're going to need to keep the one that is a negative 2x. I'm going to keep the negative 2x. And I put one check mark because it satisfies one of my requirements. Does it satisfy my second requirement? What is the second requirement? The requirement is to go back and check to see if I was to take these two terms with their sign and multiply them, does it give me my AC product with its signs? Because if it does, I get to keep it. But if it doesn't, then that is not the right term. And in this case, it actually does work out, and it actually does give you the AC product. And because it does, I am allowed to come in and split the middle term, which was a negative 2x, into a positive 3x and a minus 5x. Now, which way should we put it in here? It really doesn't matter, because whichever way you put it, it's going to go ahead and give you the correct number, which is a negative 2x, or the correct term. But to make the problem easier, I'm going to put the 3x first, just because I'm working with the 3x term first, and I know that factorization is going to come out easier. On the side, I'm going to just write this out so that way you remember that this negative 2x has been split into 3x and a negative 5x. So remember, you are not changing a problem. You're simply splitting it in the manner that it's workable. So now your expression is a 3x squared plus a 3x minus 5x minus 5. You have 4 terms. You have the capacity of splitting it into 2 separate groups and factor it. What I'm going to do is, for right now, I'm going to go ahead and highlight it with just two separate colors. So I kind of know what I'm doing when I'm factoring it, okay? I am now going to come out and try to factor by grouping, remember, a common factor from my first, the yellow highlighted group. And if you look to see, I have a group and the factor or the GCF is a 3x. When I pull out the 3x, I'm left with simply an x from here and a 1 from here. Remember, when you factor an entire term, you're still left with a 1. You're not left with a 0 because factoring has to do with multiplication, division, rather than addition and subtraction. Okay, now let's look at the second group, which is highlighted in blue. A common factor from the blue highlighted part is not just a 5, it's a negative 5. So, and a key rule of thumb in these problem is to factor out the sign for the third term, and that just makes everything falls in the right spot. So you factor out a negative 5 out of here, and let's see what we're left with. So once you factor out a negative 5 from the first term, you're left with an x, and needless to say, since we factored a negative, the sign has split, which made it a positive, and then you are also factoring out a negative from the other side, which will leave you with a positive 1. Remember, in factor by grouping, once we factor one time and we get it in this shape or in this form, the key thing that you're looking for is your factor that's in the parentheses better match, because that's what our eventual goal was. And if you look, and I'm going to highlight it, I'm going to put it with a different color pen so you can see. This over here is your one big term with a factor of 3x and x plus 1, and this over here is your another second big term after the minus with a factor of a 5 and x plus 1, and both of them have a common factor of x plus 1. Since they have a common factor of x plus 1, you are able to factor that out, and then whatever is left over, which I'm going to go ahead and circulate here, is this one here is left over, and this one here is left over. We are writing our leftovers, which gives you a 3x minus 5. And that's what your final factor will be. Now, what I want to point out is it can also be written out as a 3x minus 5 factor first, and then the x plus 1 factor afterwards. That's completely okay, because they're factors, meaning they're getting multiplied. You can switch them around, and that's not a problem at all. So remember, just the key term is the major goal for this factorization problem is to split the middle term, the x term. And we're not going to pull things out of thin air. We're going to come on the right hand side, and that's where your major work is going to be done. You are coming and you are basically pulling the first term, the A term and the C term, and working it all out, getting the AC product and using that product to come up with the middle term. And that's what we use to get to a final answer. I hope the problem made sense. Let's practice it one more time for it to come to a real clarification. Thank you for watching. Take care. Bye.